All right, so remember that according to the exam guideline, you must be able to find the resultant of, I mean, any number of forces, up to four forces, using the theorem of Pythagoras. But according to the exam guideline, you must be able to find the resultant of two vectors graphically using either the head-to-tail method or the tail-to-tail method, also called the parallelogram method. Okay, so in this lesson, that's exactly what I'm going to show you. Okay, so we have to look at this example. So two forces F1 equals to 50 newtons and F2 equals to 80 newtons act on the object as shown below. Find the resultant of the two forces graphically. Okay, so we have two forces. This is F1 and this is F2. Okay, so to solve this problem, we have to do what is called completing the parallelogram. Okay, so you have to remember, if you are taking any math class, you would recall that a parallelogram is any any four-sided shape where opposite sides are parallel to each other. So that means a rectangle is an example of a parallelogram because these two sides are opposite and they are parallel, and these two sides again are going to be parallel to each other. So this is a parallelogram. A square is another one. Okay, this side is parallel to this one and this is parallel to this one. Okay, so a rhombus as well. These are all examples of a parallelogram, a four-sided shape where opposite sides are parallel. So that's what a rhombus, that's what a parallelogram is. Okay, so to complete a parallelogram here, when given two forces that are acting at a point or on an object, what we want to do, we want to complete the parallelogram. That means we are going to draw another line. Think of these two forces as the two sides of the parallelogram. What we have to do, we have to draw in the other two sides. Okay, so this is F2 equals to 80 newtons, one side of the parallelogram. We draw the opposite side, which must be parallel to this one, F2. So what we do, we draw it at the tip of F1 and it must be parallel to F2. Okay, and in magnitude this is still going to be F2. At the tip of F2 we are going to draw F1 parallel to the F1 side, and this is still going to be F1. So we have completed our parallelogram. So this is a four-sided shape where the opposite sides are parallel to each other. We don't have to show that they are parallel to each other, but for interest sake, I'm just doing it here. This side is going to be parallel to this one, and the resultant is going to be drawn in as a diagonal like this. Okay, so of course this is FRS. Of course we're going to do this according to scale. We're not going to draw a rough sketch as I'm doing here. So now I'm just showing you what we expect at the end. Okay, so let me remove this so that it does not confuse you at a later stage. Okay, so these are the two forces given. Remember, we said this is a F1 and this is a F2. Okay, so now on this page, I'm going to draw this according to scale. What we are going to do, we are going to choose a scale. Our scale is going to say 1 centimeter represents 10 newtons. Okay, so how did I choose the scale? Look at the forces given. If I have 50 newtons and I have 80 newtons, I can't say 1 centimeter represents 1 newton, because if I said that, to draw 50 newtons I would need 50 centimeters, which is not going to fit on a page. Okay, but if I say 1 centimeter is 10 newtons, it means to draw 50 newtons. Okay, I'm going to draw a line that is 1 centimeters. That is 5 centimeters long. Remember that each centimeter represents 10 newtons. So if I draw 50 newtons, I draw 5 times that. Okay, so if I need to draw 80 newtons, this line must then be 8 centimeters long. Okay, so what I'm going to do now, I'm going to bring my ruler. Okay, so I have my ruler on screen. So now at this stage I want to draw my line, the first one. Okay, so the first line that I'm going to draw, the first vector, I mean, should I say, is going to be this one, F2, the horizontal one. So it's going to be 8 centimeters long. Okay, so let us draw that one. Let me center my ruler. Okay, so I've centered my ruler. So from 0 I measure, I draw in a line that is going to be 8 centimeters long. Okay, so I haven't got that one right. Yes, we've got that one now. So this is going to be 8 centimeters long. Okay, I've got it. So let me remove my ruler, because what I want to do now, I want to draw an arrow here, because this is a vector. Okay, so it must have arrows. So this is 80 newtons. Okay, so now next I want to draw F1. Okay, so please note that there is an angle here. The angle is 30 degrees. So this is 30 degrees above the horizontal. Again, if the given angle is 30, this one is 150 degrees. Remember that they must add up to 180 on a straight line. Angles on a straight line add up to 180 degrees. Okay, so I'm going to have to bring another ruler. Okay, not this one, and I'm going to need to bring a what they call a protractor. Okay, so let's bring that one. Okay, maybe let me bring a different one. Okay, from your mathematical instruments you can use this kind, but because I'm using a computer to draw this one, I'm going to use a slightly different one. Okay, so what I'm going to use, I'll show you just now. I'm going to use this 45 45 90 45 90 45 ruler. So the ruler that has a 90-degree angle, but fortunately for me, I also have a protractor here. Okay, so what I'm going to do, I'm going to bring it down such that the vertex, or the 0 is at the tail of the first vector. Okay, so you can do this using your normal protractor from your instruments. Okay, and then if I look on the left hand side, I can see 30 degrees. So I have a protractor here. All right, okay, and I can see 30 degrees. It aligns perfectly with 150 degrees. Remember, if I have a 30-degree angle on one side, on the other side of a straight line, if there are only two angles, I must have 150 degrees. So I'm going to put a dot here. Okay, so once I have a dot, I can remove the protractor, and then from there I'm just going to use this one, and let me sort of cheat and type the angle there, 150, so that I get the 30. Okay, so you would tilt your ruler like this, and now what you want to do, you want to draw maybe a line. Okay, you want to draw maybe a line like this. Okay, so it does look like I missed this one a bit. Okay, so let me move it. Okay, because the line that I'm going to draw must be at the tail of the first vector. Right, yeah, maybe move it up a bit. Yeah, let's just draw this line. Okay, yes. Now next step is to measure it. Remember, it must be 5 newtons. Okay, so if I put 0 there, okay, so where is my 5? Okay, my 5 is going to be, I have 0 there, my 5 is going to be here. I'm going to put a dot here where 5 is. right? And then once I've marked the length of my vector, I can put the arrow like this. Okay, so our next step is now going to be complete the parallelogram. Okay, so what we do, if you want to draw a line parallel to this one, okay, before we complete the parallelogram, let's label this one again. This is going to be 50 Newton vector. All right, okay, so now we need to complete the parallelogram. I'm going to show you how to complete the parallelogram quickly. Okay, so what you want to do, you want to put your ruler on top of this line. Okay, so if I want to draw a line parallel to F1 to the 50 Newton, this side, okay, like this, what you must do, you must put your ruler on top of the line that you want to draw. Okay, so I want to draw the 50 Newton force on the other side. I want to draw it here. I want to draw it like this. Okay, it means because this is the line that I want to draw, I must put my ruler on top of the line that I want to draw as it is right now. And then you must bring in the other ruler, the one that has a 90 degrees. Okay, so you must bring in this ruler. Well, what you want to do, you want to tilt it like this and tilt it such that it sits on top of the first ruler, and press it using your hands. Okay, so you must press it using your hands. Make sure it sits perfectly. Okay, once it sits like this, okay, push it to the top and make sure it aligns like this. Next, move your first ruler and to the other side. So there you go. You can see now I can draw a line that's going to be parallel, but I want this line to be at the tip, at the head of the 80 Newton force. Okay, so it's a matter of pushing your ruler so that they align perfectly. Your rulers, Alright, so it looks like right now they align. Okay, so they align perfectly. So what I can do, I can just draw in this line. Okay, like this. Okay, next I'm going to have to measure it. Right, so how much do I measure? Remember, this one is only 5 newtons, so I put the 0 there. Okay, so 5 is here. Where is 5? This 1 2 3 4 5. So this is where 5 is. So it means the other piece I didn't need. I only needed, oops, sorry, I should have removed the ruler, not the line. Okay, so I can just draw the arrow. Okay, so this is going to be 50 newtons. Okay, so we're going to repeat the process. Okay, so let's repeat the process. And now, because now I need to draw in a line parallel to the 80 Newton side, and I'm going to place my ruler on top of the line that I want to draw. This is the line that I want to draw. And next, bring in on 90 degrees. Okay, let's bring in the 90 degrees and see what happens. Okay, so this is the 90 degrees. I'm going to have to turn it right, yes, like this, and push it and align it on top of this one. So you can do this using your normal mathematical. It's a bit easier it's harder for me. I'm using a computer to do this, but it's going to be a bit easier for you. Okay, so once you have aligned these rulers, push this one, let's push it to the other side so that I can see the tip, the arrows of my diagram. I'm trying to align it. Please wait for it. Yes, now I can then move this ruler to the other side of the 90-degree ruler. Okay, at the tip here, voila, I can then draw and complete the parallelogram. Okay, so let's do that. So I will now draw and complete the parallelogram. Right. Okay, let me move this one. This is going to be now this one. If we have done everything correctly, it should be 8 centimeters. Right, let's see. As you can see, it's 8 centimeters. All right, so our last step is going to be to draw in. This is going to be 80 newtons, and our last step is going to draw in the resultant. So this is how we draw the resultant. Okay, draw it as a diagonal to the others from the vertex, or from the point that was given, F1 and F2, where those two forces are acting, to the other side of the parallelogram. So the resultant is going to be the diagonal. All right, so let's draw it in. So it's going to be I just moved this ruler. Okay, so now we can draw it. This is going to be let's secure it and let's draw. Yeah, this is going to be F res. Okay, so again, you still need to draw arrows there to show that this is again another vector. Okay, so if you have done this correctly, the last step is to measure the length of F res. Okay, so you can see this is going to be 4 centimeters, but this is going to be 4, in between here is 4,5, but this looks like it is 4,4 to 4,5 centimeters. There's going to be allowance there. Okay, so when this thing is marked, there's going to be allowance for errors. Okay, so this is going to be accepted. Any number that you write between 4,4 and 4,5 centimeters. Okay, so this is our F res. Okay, so we have measured that F res is going to be 4,4 centimeters. Okay, but F res in magnitude, this must be multiplied by 10. So this becomes 44,4 newtons. All right, so for the direction, what is the direction of the resultant force? Okay, so for the direction, you need to take your protractor again and measure this angle theta. Okay, so let's do that. So you need to bring in the protractor, and let's flip this and bring it down, push it to that point. All right, and the 0 point must align with the vertex or the object where all the forces are acting. Okay, so now you can see that this is going to be 10, 20, 30. This looks like it is what, 30 something. I don't know what it is, but to measure it correctly, we need to extend this line. I'm sorry for that, but we can bring in this ruler again, put it here, and make sure, okay, let's use a dotted line because we don't want to extend our vector. A dotted line does not count. I'm just extending this line so that I can measure the angle precisely. Okay, so let's put this back. All right, and now we are able to measure the angle theta. Okay, so this is going to be what, 35, okay, 37, yeah, around 36 degrees. Okay, so this is going to be 36 degrees above positive x-axis. Okay, you could give the direction as a bearing. Okay, this one takes us to the end of our video. Thank you very much for tuning in.